everyone. We are your reporters for today and we're about to discuss the two astronomers, Tycho Brahe and Johannes Kepler. Tycho Ottesen Brahe was born into a highly aristocratic, very wealthy family on December 14, 1546. He was also kidnapped by his uncle and aunt Jorgen Brahe and Inger Oxay. He was a Danish astronomer, astrologer, and alchemist, remembered as one of the early pioneers of astronomy. Tycho Brahe went to study law at the University of Copenhagen, but his parents expected him to go into politics and the law because at that time Denmark was in war. But after seeing a solar eclipse in 1560, he decided to become an astronomer instead, and later on his family supported his decision to dedicate himself to the sciences. In 1566, at the age of 20, he lost part of his nose in a duel with a classmate over who was the better mathematician, which is why he wore a metal prosthetic nose for the rest of his life. He was known for his comprehensive and unprecedentedly accurate astronomical observations. In 1597, Tycho was forced by the new king Christian IV to leave Denmark because of the rumor that he had an affair with the Denmark's queen. He went away to Prague, where he became the official imperial mathematician astronomer to Holy Roman Emperor Rudolf II. So he was acknowledged by King Frederick II, who proposed to him that an observatory be built better study the night sky. After accepting this proposal, the location of Oranienburg's construction was set on an island called Haven, the earliest large observatory in Christian Europe. The support Tycho Brahe received from the king allowed him to continue his research and make significant contribution to the field of astronomy. So, Oranienburg. Oranienburg helped to collect data constantly for studying the sky, not just every once in a while but almost every single night. He ended up to cataloging more than 1,000 new stars, and his meticulous observations showed that they didn't seem to move at all relative to one another. This meant either the stars were so far away the parallax was too slight to see, or there was no parallax at all because Earth didn't move.
Tycho Brahe has three discoveries, which are Tychonic system, supernova, and parallax. So let's start with Tychonic system. Tychonic system is the model of the universe. Tycho tried to produce a model consistent with the both of Ptolemy and Copernicus. Ptolemy means the Earth was the center of the universe, while Copernicus' Sun is the center of the solar system. The 5 planets do orbit in the Sun was Mercury, Venus, Mars, Jupiter, and Saturn. Tychonic system also said that Earth is the center of the universe. Next is supernova. In 1572, Tycho Brahe observed a new star commonly known as a supernova, that brighter than any star or planet. Tycho Brahe saw the existence of a star that ought not have been there. In year 1576 to 1591, he devoted himself to create an accurate instrument of measurement over the next 15 years. And the instrument he used is called the Hubble. Hubble can distinguish the light from the two sources and thus measure the supernova directly. Tycho Brahe coined the term nova, which means new. Initially, the star appeared a bright object in the sky. Lastly is the parallax. Parallax is an apparent change in the position of an object against a background when viewed from the locations. Tycho did not observe any shift from the new object and thus named it a new star. Describe it as a fixed star that existed in the eighth sphere. Eighth sphere, also called as a planet of death. This is a dense globe where souls failure of nature go to see the lost souls. Kepler took advantage of some confusion about the inheritance and took the data before his kids had a chance to. Kepler looked over Brahe's detailed observations on the motion of planets and realized that the planets orbit the Sun not in circles but in ellipses. Tycho Brahe became part of Johannes Kepler's breakthrough because of his data, which gave big contribution in the world of astronomy. Tycho Brahe hired an assistant, a young German astronomer named Johannes Kepler. Prior to his death in 1601, he died because of holding P. Even though Kepler was his assistant, Brahe kept most of his observations secret because it went to be passed to his children. He was a German astronomer. He was a sickly child and her parents was poor. Evident intelligence earned him a scholarship to the University of Tübingen to study for Lutheran ministry. Evident intelligence earned him a scholarship to the University of Tübingen to study for Lutheran ministry. He wrote the first outspoken defense of the Copernican system and the mysterium of cosmographium. Copernican system means that the sun positioned at the center of the universe, motionless, with Earth and the other planets orbiting around it in circular paths modified by epicycles and at uniform speeds. While the mysterium cosmographium means the orbits of the 6 known planets are supposed to be separated by the 5 platonic solids. He classified as a part of a wider subject of investigation called the science of a star. The science of a star means that the science was regarded as a mixed science consisting of mathematical and physical components and bearing a kinship to other like disciplines such as music, the study of ratio of tones, and optics, the study of light. He was called father of science fiction for his novel of Somnium novel. Somnium represents a detailed imaginative description of how the Earth might look when viewed from the moon, and is considered the first serious scientific treatise on lunar astronomy. He was best known for his laws of planetary motion and his books Astronomia Nova, Harmonics Mundi, and Epitome Harmonia Copernicani.
The 3 laws of planetary motion. Kepler's first law, the law of ellipsis. All planets orbit the Sun in a path that resembles an ellipse, with the Sun being located at one of the foci of the ellipse. Ellipse is a special curve in which the sum of the distance from the every point on the curve to two other points is a constant.
Suppose this ellipse is where the planet Earth moves. The Earth moves along the ellipse around the Sun. The Sun is located at either one of foci of the ellipse.
Kepler's second law, the law of equal areas, describes the speed at which any given planet will move while orbiting the Sun. The speed at which any planet moves through space is constantly changing. A planet moves fastest when it's farthest from the Sun. Kepler failed to explain why planets maintain their position in their respective orbit. Revolution of the Earth. The movement of Earth around the Sun in a fixed path is called a revolution. The Earth revolves from west to east. The Earth completes one revolution around the Sun in 1 year, or precisely in 365 days. The revolution speed of the Earth is 30 km per second, and we have two terms of the revolution of the Earth. It is perihelion is the Earth is closest to the Sun, and aphelion is the farthest from the Sun.
The Sun. Note that when a planet is close to the Sun, it moves fast, but when a planet is far from the Sun, it moves slowly. So if we draw an imaginary line of the movement of the planet and the Sun for every month of the year, we can see that when the planet is close to the Sun, it will form a wide but short triangle. and when the planet is far from the sun, it will form a thin but long triangle. The Earth would have to adjust its movements in order to match the imaginary area. Did you know that the knowledge of Kepler's second law has proved the importance of Newton's law of gravitation? Newton showed that the motion of bodies subject to central gravitational force does not always follow the elliptical orbits as specified by the first law of Kepler, but instead, planets or other heavenly bodies can take paths defined by other open conic curves.
Kepler's third law, the law of harmonies, compares the orbital period and radius of orbit of a planet to those of other planets. Unlike to the first and second laws that describe the motion characteristic of a single planet, the third law makes a comparison between the motion of characteristic of different planets.
A planet to those of other planets. It is the ratio of the squares of the periods to the cubes of their average distances from the Sun is the same for every one of the planets. The comparison of each planet can be shown in this illustration. Now, what does that mean? Kepler's third law means how long a planet takes to go around the Sun.
Kepler's astronomical works. Mysterium Cosmographic. This book explains Kepler's cosmological theory based on the Copernican system, in which the five Platonic solids dictate the structure of the universe and reflect God's plan through geometry. According to Kepler's account, he discovered the basis of the model by demonstrating the geometrical relationship between two circles. He wrote, "I believe it was my divine ordinance that I obtained by chance that which previously I could not reach by any means." Astronomia Nova, one of the most significant books in the history of astronomy. The Astronomia Nova provides strong arguments for heliocentrism and contributed valuable insight into the movement of planets. These include the first mention of the planets' elliptical paths and the change of their movement to the movement of free-floating bodies as opposed to objects on rotating spheres. It is recognized as one of the most important works of the scientific revolution. System of Copernican astronomy. The brilliant German mathematician Johannes Kepler, one of the founders of modern astronomy, revolutionized the Copernican heliocentric theory of the universe with his three laws of motion: that the planets move not in circular but elliptical orbits, that their speed is greatest when near the sun, and that the sun and planets form an integrated system. Rodolphine tables. The tables are named in memory of Rodolph II, Holy Roman Emperor, in whose employ Brahe and Kepler had begun work on the tables. The main purpose of the Rodolphine tables was to allow the computation of the position of the then known planets of the solar system, and they were considerably more precisely than early such tables.
We hope you understand the contribution of Tycho Brahe and Johannes Kepler in the world of astronomy. That's all. Thank you for listening.